Okay, so this is our last part of the digestive tract. So we're going to talk about some nutrition and nutritional issues. So first off, where do calories come from? The definition of a calorie is it's the amount of energy or heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. All right. Next couple things I want you to see here is 35, let me get my little highlighter out. 3,500 calories equals 1 pound. Okay. So there's all these crazy diets out on the market where people say, do the Atkins diet, eat all this protein, or eat all vegetables, or eat all this, or eat all that. Here's the gist. Calories in versus calories burned. If you burn more calories throughout the course of the day than you eat, then you're going to lose weight. If you eat or take in more calories throughout the course of the day than you burn, then you're going to gain weight. I like to describe to people that when they're talking about weight, when they're talking about diets and stuff like that, first thing I always ask is what kind of stuff do you drink? Do you drink water, pop soda, whatever, juice, coffee? And then my next question is it regular diet? So let's just do this simple equation of that. You drink 2 cans of regular soda per day, 1 at lunch, 1 at dinner. They're 120 calories each. That means each day you have 240 calories from pop. In the course of 10 days, that's 2,400 calories. In the case of 15 days, that's 3,600 calories. So every 15 days, you're drinking 1 pound worth of calories of pop. You follow that? So just take in less calories. Simply cutting out pop from your diet is an easy way to lose some weight. Okay, next one. Depending on what you're eating, different stuff has different amount of calories per gram. So lean protein has 4 calories per gram. Carbohydrates, 4 calories per gram. Fat is 9 calories per gram. And alcohol, 7 calories per gram. So that's just saying that fat is going to be more calorie laden than carbohydrates or proteins, for example. And then vitamins and minerals, they don't have energy but in the form of calories, but they're going to help with chemical reactions to make energy. Okay, so next up, we got basal metabolic rate and resting metabolic rate. BMR is going to be calculated using an equation based on your height, weight, age, and sex. Resting metabolic rate is going to determine the amount of calories you burn based on how active you are. And you're also going to take in your height, weight, age, and sex. So resting metabolic rate is a little bit better, I believe, than basal. Our next thing with metabolism is there's something called BMI. Here's the equation for it. Pounds times 703 over square inches. Inches squared. Normal weight, you want to be between 18.5 and 24.9. If you're overweight, it's between 25 and 29, and if you're obese, it's 30 or greater. This equation is good as a general rule of thumb just to see how tall you are and how much should you weigh for your height. But when you start looking at like muscle heads or bodybuilder guys, they quickly become obese according to the BMI. Or me, for example, you guys have all know me and seen me before. My BMI is 24.5 is my BMI. So I'm at the borderline of being overweight, and I personally right now at this time in my life don't believe I'm overweight. So I think the best way you could really calculate BMI is to do something that includes height, weight, and your body fat percentage. That would be a much better gauge. Okay, so going on, our sources of energy, we already talked about it. We get fats, proteins, carbohydrates, and alcohols. Fats were 9 calories per gram. Proteins and carbohydrates were 4 calories per gram. All right. With fats, your body is going to use the free fatty acids and ketones. With proteins, your body can change it into glucose, and with carbohydrates, those are just used basically as glucose. When you talk about the Atkins diet, if that's going to be removing carbohydrate intake from your body as much as possible, and what happens is the body's going to start to break down protein for glucose. okay? Protein metabolism will slow, and the body's going to break down fat for its main source of energy, okay? When it breaks down fat, you get ketones and free fatty acids. Here's the trick here. Your brain likes glucose. Your brain wants to use glucose as its energy source. If it runs out of glucose, then it goes to ketones. So if you ever knew anybody or know anybody that was on like an Atkins type of diet, when they first start that diet, they are crabby and mean people. Why? Because the brain's getting used to using ketones as its primary energy source versus glucose. Okay, food groups. Here we go. I think that, in my personal opinion, I would take these fruits and these vegetables and fruits here and put them on the bottom of the food group. But this is the food group recommended by the USDA. All right. I believe fruits and vegetables should be at the bottom. And then you should have grains above those. But whole grains and oils, plant oils, very, very specific plant oils, not meat oils. Then we got our vegetables and fruits, nuts and legumes, fish and poultry, dairy and calcium, and then we get our red meat and oils in your rices and breads and pastas and stuff like that. Okay, with amino acids, so amino acids are the building blocks to our proteins. We have essential amino acids, which are going to be amino acids that our body cannot make, and then we'll have the other amino acids which our body can make. Okay, what we're looking at on this chart is that when you eat a meat like chicken, fish, steak, something like that, when you're having meat, it's coming from an animal. When you eat animal products, those animal products are going to have all of the amino acids inside of them. When you eat vegetables, you need to have, if you're a vegetarian, it's important to have a wide variety of a diet of eating different vegetables, because there's no single vegetable that's going to have all the amino acids, all the essential amino acids in it. So you're going to want to eat a wide variety of vegetables so you will have all the essential amino acids so your body can work at its optimal level. Okay, so how do we make energy? First, you're going to eat food and you're going to digest it in your digestive tract, GI tract. Next, anabolism is going to occur, all right? Anabolism, and catabolism. So anabolism is going to be building stuff. Catabolism is going to be breaking stuff down. So here we have glycolysis, glycolysis. It's literally the breaking. Lysis is breaking and glyco is for glucose. So we break glucose into two parts. And then the last part we have here is our oxidative breakdown, which will be the Krebs cycle, also known as a citric acid cycle. And we have oxidative phosphorylation, or the electron transport chain, which will occur in the electron transport chain. So going one step further, here's what I want you to know about this. Let me get a pointer. Glycolysis is anaerobic. It is anaerobic. It does not require energy. This happens inside of the cytoplasm. So here, it happens inside of the cytoplasm. Cytoplasm is basically, think of it as water. So there's no oxygen available for it. The Krebs cycle and the electron transport chain occur inside the mitochondria. These guys are both going to use oxygen, so they're considered aerobic. So glycolysis is our anaerobic respiration. Krebs cycle and electron transport are our aerobic respiration. Krebs cycle and electron transport chain occur inside of the mitochondria. Next thing I'm going to want you to know, glycolysis, once again we said it happens in the cytoplasm. It's anaerobic and it's going to have a net gain of 2 ATP. With the Krebs cycle, that happens in the mitochondria and is aerobic because it uses oxygen. That's going to once again have a net gain of about 2 ATP. And then finally our electron transport chain. The electron transport chain is going to make a whole ton of energy. It's going to make about 28 ATP. So it's going to be our long-term energy source. So if you're doing some sort of cardiovascular or long-term activity, it's going to be using stuff from the electron transport chain. Okay, so foods. What happens when we eat foods? So you eat your dietary intake, and it can either be brought into a pool of carbohydrates, or it can be brought into a pool of free amino acids. All right, carbohydrates and fats, amino acids. So proteins go over here, fats and carbohydrates go over here. A byproduct of proteins is urea. Okay, if you get too much urea, it's going to be excreted in the urine, or uric acid. So if you get too much urine in the can all be excreted in the urine, it starts to build up in the blood, and that could be the cause of something else called gout. Okay, so we take the free amino acids, we use them to build proteins, whatever you need to do, whatever kind of proteins we need. Other stuff, we make nitrogen containing stuff. Hormones, neurotransmitters are the main things you think of there. Okay, come over here, carbohydrates and fats. Well, cell membranes are phospholipid bilayers, right? So they're fats, they're made up of lipids. So we'll use these to make our cell membranes. Will be fatty derivatives right here, so like steroid hormones, bile, stuff like that. Carbohydrates, great source of energy, so are fats, and then we can use these also to store energy. Okay, nutrient absorption, so your GI tract is going to absorb nutrients. Glucose can go pretty much anywhere. We can send glucose straight to the muscles, where it can be stored as glycogen. We can send it to any tissue to make energy. We can send it to fat, and it can be used to make more adipose tissue, or it can be brought to the liver and it can be used for energy, or it can be stored as glycogen. Amino acids can go to the muscles to produce proteins, or they can go or they can go to the liver to produce proteins. Fats are going to go to the adipose tissue, and they're going to help out with the production of fatty acids. They can also be processed by the liver. Okay, so this is just daily recommendations of how much of each thing you should have. So we got carbohydrates. We're going to have two types. We're going to have complex carbohydrates and simple carbohydrates. Complex carbohydrates are going to be like bread, cereal, nuts, rice, potatoes. These are going to be a long-term energy source, your complex carbohydrates. Simple carbohydrates, think sugar, like a candy bar. Okay, quick burst of energy. If you eat too many carbohydrates, typically you're gonna gain weight. You can become obese. If you don't have enough of them, you can have tissue wasting, and if you have that would be a really extreme case. So that would be somebody who's like on an Atkins diet. They're having tissue wasting. They're gonna have accelerated fat use for energy. So if you do that diet for too long, it becomes a problem. You do that diet for a short period of time, it's a quick way to lose weight, but a lot of times when you lose the weight too quick, it comes right back. Okay, so we talk about glycemic index. With glycemic index, all we're seeing is it a complex carbohydrate or is it a simple carbohydrate? Simple carbohydrates are sugars. So if I eat a simple carbohydrate, it's going to break down immediately. Like if I need a sugar boost, I drink a can of pop, or I have a candy bar and I get a boost of sugar immediately and I get some energy quickly. If I have that would have a high glycemic index. That would mean that it's a quick source of energy. Stuff with a low glycemic index would be something like a potato or pasta or wheat, stuff like that. It is harder for the body to break it down, and it will be a longer source of energy. You typically want to stay away from foods that have a high glycemic index because they're sugary. Okay, next one, lipids. So there's going to be different sources. So we can have animal fats, plant fats, essential fatty acids, and then our cholesterols or trans fats. All right. So most of the intake of lipids is going to be from your animal fats. Okay. Then our plant sources. Then your essential fatty acids. I would like to see most of your fats coming from your plant sources versus your animal sources, to tell you the truth. Okay, proteins. There's complete proteins. That is going to be from any animal-based product. Fish, red meat, pork, chicken, whatever looking at. Incomplete proteins, these are going to come from vegetables or plant-based products. The reason why these are complete, they have all the amino acids in them. The reason why these are incomplete, these are missing some essential amino acids. So you need to have a wide variety of them to ensure that you have enough or all of those essential amino acids. Okay, vitamins or minerals, here's what I want you to pull from this chart. What the mineral is, what the damage can be if you don't have it. Okay, iron, the only one I'm going to spend any time on talk about right now is iron. So iron is, women typically need more iron than men simply because of menstruation. So when they're losing blood once a month, they are going to be losing iron with it, and you're going to want to be replacing that. Okay, so fuel mechanisms. We already said the brain likes glucose, right? If the brain doesn't have glucose, it will back up on ketones. Skeletal muscle, it's going to have glycogen as a fuel store. It likes fatty acids, okay, and there's no fuels it exports. When the muscle's in exertion, it likes to use glucose. All right, if it needs to export stuff, it can export lactate, which it ends up doing. Heart, it's always going to use fatty acids. Well, it's not always, but it's really going to want to use fatty acids. Adipose tissue uses triglycerides as a fuel store. It likes to use fatty acids as its preferred fuel. Liver can store energy in triglycerides and glycogen, and it likes to use amino acids, glucose and fatty acids. Okay, hormone effects. Stop and think about what hormones do, and the effects make sense. So insulin is going to help lower our sugar levels. So cells uptake glucose. Okay, they stimulate amino acid uptake. They stimulate glucose of catabolism, glyconeogenesis, lipogenesis. They're going to make you store energy, produce fat, make stuff. All right, so these are going to be building. Glucagon makes us release energy, so we're going to break down fat. We're going to break down our glucose, stuff like that. Epinephrine, fight or flight, it's going to do the same thing. Growth hormone, think of people with growth hormone. They're bodybuilders. They're trying to get big and bulky, so protein synthesis. They don't want fat, so it helps break down fat. All right. Thyroxine, that's going to help us store sugar, build lean muscle, and break down fat. Cortisol is going to have us store fat, and testosterone is going to help out with muscle building. Okay, medical impact of nutrition. Big point of what we're looking here is that what you eat is a very powerful tool. Many diseases, chronic diseases that people are dealing with in this day and age can be dealt with by changing your diet and having a healthy diet. Okay, moving forward from that, leading cause of death in the country right now, heart disease. Why? Poor diet. People eat McDonald's and Dunkin' Donuts and Burger King for most of their meals. Okay, check out these obesity trends. So in 1990, there was a behavioral risk factor surveillance system. Okay, it said that less than 10%. Here, let me just show you the charts. Check this out. Here's 1990, 1998, 2006. This means less than 10% of the states had obesity as an issue. This is 10 to 14%. This is over 15%. In 1990, there wasn't a single state where there was over 14% of the state having obesity issues. In 1998, most states were between 15 and 19%, and there were a couple in the 20 to 24% range. In 2006, and now I believe that almost every state is above 20 to 24 in this day and age. So every state is above it. But look at that. So it's just a larger and larger proportion of the country is becoming obese. And that's it.